Okay, so first thing we're going to get started with quiz 1A, which is the one everybody failed at the beginning of the year. Question number 1. So you're given this table and you're trying to figure out what the profit you're going to expect on a day-to-day basis, given that these are the probabilities of selling Y sunglasses at $15 each and X flip-flops at $10 each. So you're given this table. I've written out the probabilities for the 4 days where it is possible to put X's where that's never going to happen. And then what I did was I computed how much money you expect to make on that day. So here if you're selling 1 pair of sunglasses and 0 flip-flops, it's 1 times 15, then 0 times 10, so you get 15. Just another example here, you're selling 3 sunglasses, so 3 times 15 is 45, plus 1 times 10 is 55. So you see the table I've written out here, you get 75 here and 90 here. So then next thing what you have to do is compute the expected value. The expected value is the sum of what you expect times the chance of it happening. It's kind of basically like a weighted average. So you take 15 times 0.6, which we have back here, 55 times 0.2, and then you just continue it out to 75 times 0.1 plus 90 times 0.1. However, there is an extra caveat in this question. He says that there's a standard business license, which is $3 a day flat rate, so that's why you're subtracting 3 from here. If you want, you could also do 12, 52, 72, and 87, but those would also factor out, so it comes out either way. So you just subtract 3 in general, so you get 36.5 minus 3, which is 33.5. Then you need to find the standard deviation, which is this formula we've written here, which is whatever your expected profit is minus x bar, which is the average, which we just found, or also e sub x would probably be more accurate. You square that, multiply it by the probability of that event occurring. So 12 minus 33.5 squared times 0.6. Notice that it's 12 instead of 15 because you have to subtract out the 3 ahead of time this time. So that's 12 taking into account the daily business license times the 0.6 probability. You sum those all out. I don't know, I haven't written them all out here, but you should get a standard deviation of 27.9.
Cool.
Okay, so continuing in quiz 1A, question 2 asks us for a confidence interval. Bottom line, as he's explained it, a confidence interval is your best guess plus or minus just some leeway for error, essentially. So the formula that we usually use is x bar being your mean plus or minus z star times your standard error. Z star, when you're given a confidence interval, you're given a percentage, like 95% is one of the most common ones, and you need to find that z value. I'm using the notation z star for that, don't let that throw you off. So you're given these 4 pieces of data, 250, 265, 270, and 290 for the value of property. So when you take the mean of those, which you all should know how to do, you get that value. And you're told that the standard deviation for the entire population is $20,000, but we can't apply that. We need to adjust it for our sample. So we need to take our standard error, which is equal to sigma over square root n. So you take 20,000 divided by 4, which is, the square root of 4, so 20,000 over 2 gives you 10,000. So then you get x bar plus or minus. We just need to plug it into that formula. So we get 268,750 plus or minus your SE, which is 10,000. And then your z star, look up your z star. Basically in a z table you'll find that for 95% it's 1.96, giving you a solution of 2. That's a 9 by the way. 350. So basically, it's 249,150 to 288,350. Look out, Professor Lin does usually tell you what he wants you to round to. Make sure you round to those values. All right, question 2, continuing on. Again, it's about confidence intervals. So if let's just rewrite our confidence interval formula is equal to x bar plus or minus z star times your standard error. Okay? But this time, what we're trying to find is n. So one of the biggest things about Professor Lin's quizzes is there's a bunch of different ways to solve things. There isn't an exact formula to find the size of a confidence interval. If you want, you can memorize that, or a little bit of algebraic, just manipulation will help you solve this problem. So we know that we're trying to get we're trying to get our estimate within $2,000. So that means that this portion must be 2,000 on each side. So that means SE times 1.96 is equal to 2,000. Solve out for that, you get SE is equal to 1020.4. And from the previous time, we know that standard error is equal to sigma over square root n. And we know that sigma is 20,000, which we had written. We had that written down right over here. Sigma is equal to 20,000. And so we bring this one back. Standard error is equal to 20,000 over square root of n. And now we've got, we know that standard error is 1020.4. And our standard deviation, solve for square root n, and then n, and you get 384.16. But you're talking about people, you can't have 0.16 people, and you can't round down, otherwise your estimate will be too small. So you need 385 people, so you just need to round up. Okay, so last question for quiz 1A, question number 3. You're told there are 18 students in a class, 4 of them fall within a certain height range and are male, and you want to know what are the odds of, when you're picking 3 of them, that you get at least 2 or 3 of them. So there are 2 ways to do this. The first way is to use the conjugate rule, which is where the probability of 2 or 3 is also equal to the probability of not picking 2 or 3. So it's 1 minus the probability of not picking 2 or 3, which is 1 minus the probability of 0 minus the probability of 1. So once we solve that out, so probability of 0, so the first time you select a student, you've got 14 out of 18 of not picking one of the ones we're talking about. The second time you've got a 13 out of 17 and 12 out of 16. These are decreasing because we're not replacing them. Then the probability of 1, so 14 out of 18, again, so we don't want somebody in the range. 13 out of 17, don't want someone in the range. But then we want one person within the range, and we still have 4 of them left. So it's 4 out of 16. But the reason we multiply by 3 is we don't know if the first person is going to be selected at this spot, or at this spot. So that's why we multiplied by 3. You solve that out, you get 10.8%. Alternatively, to solve this question, you can do it the other way, which is the probability of selecting 2 or 3 without the conjugate law, which is equal to the probability of 2 plus the probability of 3. You're essentially doing the same amount of calculation. For the probability of picking 2 of them, that's written down wrong. Yep. Should be 4. Okay, so for the probability of picking 2 of them, it's 14 out of 18, again, so because we want one of them to not be in the range, and then 2 of them to be in the range. So 4 from the first time, and 3, because you already took 1. Again, you multiply by 3, because you don't know if the 2, so if we say there's 3 spots, 1, 2, and 3, your combinations could be 1, 2, 2, 3, or 1, 3. So that's why we multiply by 3, because there are 3 ways that we can pick 2. And then pick 3, there's only one way you can pick 3. You have to pick one every single time. 4 over 18, 3 over 17, 2 over 16. Solve that out, you get 10.8%, which is the same percentage we got last time. Did I block myself?